Moving right along into 3.4, the dot product, much less to get through than 3.3. 3.3, we had to introduce the entire concept, so that's why there's so many dang videos. 3.4 will just have a few. I think the process is pretty straightforward, especially if you get a full understanding from 3.3. Go do those problems out of the book, make sure you got them. It's the same games, I'm going to ask you the same stuff on your worksheets, so make sure your worksheets and your homework in the book is solid. And I think you're not going to find that this is the more challenging thing. The most challenging stuff is behind us. So as long as we progress, don't jump to 3.4 before you've done 3.3. I think you might be able to just walk right through. Let's go. The dot product. Well, the first thing we want to talk about is this little implication. We dot product. We dot two vectors. So we got vector u and we got vector v. We're going to dot those two things together. Now it looks like there's a multiplication in between those two vectors. And sure, yeah, maybe it's this weird ass multiplication, but it's not. It's not. I mean, what the hell does it even mean? What does it mean? You're like, I'm going to take this thingy times that thingy. Well, what? You're going to take the direction and magnitude and just multiply it by another direction? And tell me what that turns out to be. I'm not really sure. But here are some things that appear to be like multiplication. It's called the dot product. And there's not much to it. There's really not much to it at all. It's by taking your components. If you look, u dotted with v, it's just taking your first, takes your vertical or your horizontal components and multiply those two together. Next, you're going to take your vertical components and multiply those two together. And then you add them up. So, not too much to it. We're going to practice a couple right now so you can see that this is uber mellow. Uber mellow. Excuse my dog in the background. That's not probably going to go away. Alright, so we want to find this. The question say, go find v, vector v dotted with vector w. Cool. So the way this is going to work, it is literally, we're going to put a plus sign. Now, you're going to take these two things and multiply them together. Here we go. 3, -1. All right, next. Hold on, it's going to get super tricky. We're going to multiply those two numbers together. You okay? Real good? Hanging in there? Multiplying them together. So what does this turn out to be? We look, we're like, well, that's -3 minus 2. That's equal to -5. Cool. You know what that means? Nothing. It's just a freaking number. But it's going to be a number that we'll find out later actually has a big use, has a value. It's something that will work out great for us. When I go through and I'm going to do a proof for you, and right in the middle of the proof, I'm going to ask you a quiz question. So make sure to watch that one, okay? So v dotted with w, really the only thing this tells us, we'll learn later, is that the angle between the vectors is larger than 90 degrees. It's larger than 90. It's not less than 90. But that's about all we learned from it. Okay, moving on. Mechanics. All right, cool. Here we go. Now we're going to dot these two vectors together. Not too much to it. We're like, all right. Vector v dotted with vector w. Now look, oh, wait a second. Wait. What was this answer? Was this a vector? Is this a vector? Absolutely not. No, it's not a vector. This is a scalar. It's just some freaking number. I forgot to mention. I was just saying, hey, look how silly it is. It's just a freaking number. It doesn't mean shit. But it's not a vector. When you dot two vectors together, it becomes a scalar. Make sure you have that. When you dot two vectors together, it becomes a scalar. It's just a number. It does not create another vector. Okay. Going back. Hey, look at these two vectors. We're about to dot together. And we're just going to get some random ass number out. All right. Let's do it. So the first thing is like take these two, right? We're going to multiply our horizontal components together. Cool. So we multiply our horizontal components together. Like neat. And now we got to multiply our vertical components together, right? These ones. 0 times 15, or negative 15. Make sure I get that in there. Get the problem right. Okay. So what do we get? Negative 14 plus nothing. So we find out again, we got vector v dotted with vector w is equal to negative 14. Oh, again, if it's negative, it's between 90 and 180, not inclusive. Cool, we got a freaking number. Fantastic. That's spectacular. We're just looking at the mechanics. Let's keep going. All right, vector v dotted with vector w. This one actually has a little bit of a special meaning to it, and what the hell? Well, let's introduce some fractions. I know how much y'all love fractions, and if I give you some questions on a worksheet that have to do with fractions, please make sure you give it back to me in a fraction form, not in a decimal form, okay? Cool, so we're gonna take this again, and we gotta, what was that? Oh yeah, we multiply our horizontal components together, and then when we're done with that, we multiply our vertical components together. And then we just add those two things up. So we got 6 times our negative 1/3. And now, can you see how simple this would be if you could just do this shit in your head? You know, write this down. No? I wish I could. I don't have that brain power. All right, so let's look. We got negative. So get the negative out. So 6 divided by 3, that's negative 2. Okay, cool. And then 10 divided by 5, that's equal to 2. And negative 2 plus 2 is equal to 0. Well, 0 has a very special meaning when it comes to vectors, when you dot them. We're going to have a whole slide dedicated to this, and this means that they are orthogonal vectors. Perpendicular. Think that. We'll be back for it later, though.